Hi, in this video, we'll watch an AI take OpenAPI specifications and turn them into a running application. We'll see that while the AI stumbles along the way, it leverages feedback from the OpenAPI specifications as guardrails and gets it right in the end. We're going to ask an AI to build an order service. The order service will have an API for creating orders, and this API in turn will need to make a request to the product service, which is the downstream dependency, for certain details like the product price or the product description. The product service will return a response, and both request and response will be as per the product service OpenAPI specification. In fact, the order API service will have its own OpenAPI specification for its APIs. We will feed both these API specifications to the AI and ask it to build a running order service application. Let's see how this works in practice. Here's the OpenAPI specification of the order service, and to its right, the OpenAPI specification of the product service, which is its dependency. We're now going to feed both of these API specifications to the Specmatic agent and ask it to generate a running order API. Let's see this work. So the agent started off by asking the LLM to generate a node application. The LLM has responded, and now it's time to use some tools. So first, the application is being started up, and the stub and some contract tests have run. They failed, which the AI has acknowledged. It's going around for another pass. Here we go again. A couple more files have been updated. The agent's starting the application up, running contract tests again, and this time it succeeded. So when the contract tests succeed, this is the clue to the LLM that everything is working as it should, which means the order service is running and has successfully passed the contract tests and thereby is adhering to its OpenAPI specification. And that is when it tells the agent that it's time to call it a day. The job's done. All right, let's now roll right back to the top of the logs and see what actually happened. I was giving you running commentary about what was happening, and I'm not going to go over that ground again. But let me just call out certain salient points. The LLM first sends down a few files to write, which the agent dutifully writes down to the file system, and then a few instructions to the agent for tools to run, each of which the agent follows. A couple of interesting things. After starting the application, the agent starts a stub based on the dependency specification. Why does it do this? Because the application needs its dependency to talk to if we are going to run contract tests against it. And we have only asked the LLM to generate an order service, not the product service. So what then is the order service going to talk to? And the answer is Specmatic has a way of stubbing out a dependency based on its OpenAPI specification alone. And this way we can quickly get up and running a stubbed version of the product service for the order service to talk to. That's what's happening here. The first tool that runs starts up the application. The next tool starts up a dependency, and now the application is ready for the contract tests. So that's what's happening here. And the contract tests run against the application. Let's see the results. Immediately, we see a test has failed. This is a negative test. What's happening in this test? This is the crux of the test. So it turns out that in the specification, discount coupon is not a nullable string. So you can't really pass null to it. If you're passing it, it's got to have a string. And Specmatic decides to play around with it and see what happens, how the application reacts if you do pass a null. Ideally, it should return a 4XX, a 400 series response, but it returns a 200 series response. It returns a 201, which isn't great. And so this negative test has failed. Specmatic articulates this very clearly, and this is great because an LLM can read this, understand it, and adjust accordingly, as we'll see below. There are a few more errors of this type. In fact, if you scroll even further down, and here you see the unsuccessful scenarios in a handy summary. Once again, feedback for the LLM. 7 successes, 3 failures. And if you scroll further down below, you'll actually see some of the output from the stubbed dependency, which the LLM asked the agent to start at the beginning. But I won't spend too much time here to understand how dependency stubbing works. You can look up other videos of Specmatic. Scrolling down past this, the LLM acknowledges that the tests have failed and circles back for another try. It writes 2 files back out, and once again instructs the agent to perform a similar set of steps to before. But this time, when you scroll down, you'll see that the contract tests have all passed. including this one. This time when Specmatic makes this API call and passes null as discount coupon, we get a response saying that this should be a string, which is great. The application's now behaving the way it should. And when the tests pass, that is the signal to the agent that its job is done and the application has been generated successfully. As you can see, the journey from API specifications to running application was not without hiccups. The LLM missed the mark on the first try, as we could see from the contract test failures. This is expected because LLMs are non-deterministic by nature, and it's but natural that they would need deterministic feedback to help them stay on track. The feedback in this demo came from Specmatic's contract tests, wired up as a tool available to the LLM via the agent. And indeed, the LLM leveraged the contract test feedback, learned what it had gotten wrong and fixed it, thus going independently from API specifications to working application.